Hi all. First of all, very nice to see you all in 3D, in person, the kind of meaty, bulky persons that you are. And taller than it seems, always. I'm always surprised about how tall people are after seeing them on the webcam. So yeah, HellOps. So this talk is again a bit of a rant. So I take this opportunity in order to talk about something of the software world that I don't see as a developer. I don't see exactly right, or as I see a gap for improvement. So let's go for it. Uh, yeah, a little story. This is, well, I just learned yesterday that this guy is called Jack Skellington, I think. So he's a developer, and he's on PagerDuty, and he gets like an alert in his on his mobile. So he wakes up and he sits in front of his laptop and finds an email that is coincidental with the alert, and that email contains a link. So he clicks on the link, and that's what he sees. Suddenly, his IDE opens up at a specific place. So the IDE is in debug mode. So the server, what happened is that the server had some exception, some error, and the IDE is exactly paused at the point of the exception in his IDE. He's got a running REPL. For Clojure developers, we know what that is. Running against that problematic server, perhaps he's got the last server logs at his disposal in order to troubleshoot. This looks great, right? What happened in between? So the faulty server was automatically put in quarantine. No real users can actually connect to it, but well, Jack can. Has been disconnected from backend servers because it could cause more harm than good. But actually, Jack could decide to reconnect it to some of those. Another instance has been spawned to replace that server, and the developer has all kinds of information. So there are some examples in there. So user journey before the issue was collected for him, across service trace, maybe there are several services involved, and he's got like a correlation ID and everything is there, and maybe even as a database snapshot. Here, a reference to XTDB, so XTDB can do this. But well, there is a problem with all this, and the problem. Well, I'm not sure if you have seen this in your everyday job or practice. Do you see this kind of approach to problems or so? Yeah, so that's a problem. This is a fantasy. So, and it's a lie. So I have made it up. But there isn't anything in there that is actually so technically challenging. So this is actually doable, pretty much of it. So that's the the subject of my talk. My feeling is that even at this in 2025 still, right? We are like I find developers a bit too distanced from the real production software. So the software running in production, and what I find is that this is actually quite time consuming. I'm not sure what your experience is in general, but that's mine. So what are we doing in order to solve this? Yeah, DevOps, right? DevOps to the rescue. So we want to have. I learned also this week that the DevOps term was coined in 2009, I think. So like 16 years ago or so. And yeah, the goal, the original goal was, I mean, let's have developers run their own production server. So that, like, having developers in charge of production pretty much directly. So the developers become operators, and operators are also developers. So they are all, and they are in a single team. So being more shifted towards development or towards operations is more of a skill issue. So it's a specialization. But actually, what I have seen happening, so it depends on the company. Uh, some people get to closer or farther from this extreme, right? So I have seen some companies that, well, it's like for every buzzword that comes to this industry, everybody wants to be doing it. So whatever they are doing, they will call it that way, even if, if it's got no relationship with it. So yeah, that I have seen that happening actually in my company some years ago, in the company I was working for. So just operations just got called DevOps because of the of the buzzword. They didn't do anything different. Maybe they were starting to do a bit of infrastructure as code, but not much more. Um, and then infrastructure as code. So what I have seen is that, so this is great. So having your infrastructure declared as code and you check it into your versioning system and everything, you control the changes, you can have reviews. It's great. But sometimes I find it problematic because it comes as a replacement to other more direct ways to interact with the production software. And it becomes a problem because as soon as you check in code, then there can be a CI pipeline. There are code reviews ongoing, and you cannot do that, or you shouldn't be doing that for easy dynamic changes such as logging, as I mentioned there. So having ceremony for changing the logging, like logging level of a production server, is just a pain. It's not practical. Or changes that for to deploy them cause a full redeploy of a bunch of servers, which is not practical in production. Things like that. Yeah, I have an additional comment there. What I see sometimes as well is like for code that is responsible maybe for deployment for operations. Sometimes different tooling is introduced. So like for example, just shell scripts in order to do certain things. And sometimes your own programming language is already good enough in order to do some automation. So what I find as well is that sometimes there are more things to learn, which puts a bit of a barrier to developers into getting to how to modify or to learn how operations are done. And yeah, while thinking about this talk, I came across this article. This is a recent article by the Bitforge that appeared on that dev.to website. It's called 10 developer habits for between good and great developers or so. I don't know. I don't like to talk about good and great developers, but yeah, this is one of his points is very similar So let me read that second paragraph out. So great developers have an intimate, ongoing relationship with production. They don't just ship code and forget it. They watch it walk out the door and follow it into the world. They treat the production environment not as a final destination, but as the ultimate source of truth about their code's behavior, performance, and value. So that's more or less, I think it's a good summary of my talk as well. So these are my suggestions. Use production as your bench, or try to use it. Challenge the assumptions that you thought at some point you were doing. Like, for example, it could also be business assertions. So if some product owner tells you that some things shouldn't be used too frequently, just put something in the code that tells you about that and check that assumption. Or all the time, if something can go wrong and you have an easy way to check it, just leave it there in your code, make it explode when that happens. Also, not just by running code that does something, just put code that is run explicitly to check for those things. So, for example, when I say there schedule sanity checks, it could be like checking like invariants in your database, for example. Just schedule something that goes through all your user base and checks for some invariants in there. I tend to be very fixated in like tweaking logging to the extreme. So choosing the right log levels and the data they contain. Be ambitious about the metrics that you're collecting, also the data that you are showing. Don't be afraid of collecting like details. So many times we talk about metrics and we tend to think that that's the only way to learn about the executing thing, but you can actually collect details. Just use dedicated tables in your application for that. And yeah, there's another whole theme in there about running tests in production. That's actually something that some companies do. So they have their production, they actually have batteries of tests running on their production system. And yeah, you can also define, put your tests, your test abilities like an additional feature, like treat it as if it were an actual feature of the application. So if you want to test, as you probably want to do, like if you have a consumer application, you will naturally want to be testing with consumers, like acting as a user. Just define test users that are first level. So you have users that are qualified as tests. You don't take them into account in order to do the reporting about the application. But that's your way to do tests. And build administration or technical UIs for that. So what can we do? The thing is that we can do a lot of things, and putting together, like the first example, it's already a lot of work. So it's not that we should try to be like, to take this to the extreme, but we can do something in our current position. So do what you can do. Don't accept what is already established in terms of practices or existing systems. Do not get trapped into static configurations. That's very easy to with infrastructure as code. It's very easy to get trapped into that and not being able to do changes fast. Of course, security is an aspect that will go against this in many times. So that's something that you need to look for solutions for. And build if the ambience is not favorable, if you are actually distance from the production servers, think about building functions into the software with the following expectations. So productivity, this is looking for productivity. I think these, I said, these are very time-consuming things. So productivity is expected to be boosted a lot. And there is an additional, usually when you boost productivity, usually you see like a qualitative jump as well. So sometimes when you are fast and doing certain things, that you can eliminate that burden and start thinking a bit ahead and about more ambitious features and such. And yeah, that is all then. My thought.